Hi everyone, Christian here. We've finally reached the beta testing phase for the ceiling tool, so I'm going to do a little demo clip to run you through basically the way it works. So let's take a look. Okay, we'll just go back to the default settings, as that's probably a better place to start. Okay, so first thing to note is that the user interface is by no means complete. There's 3 pages at the moment: info, configuration and representation. The info will just be a title page. It'll be that same image, I assume, and it'll be basically a link to support. The configuration page will be separated. These are basically just the parameters that you will need in this interface to control certain aspects of the object, obviously. So first we have the panel design, so that allows you to basically configure your panel arrangement, overall position. This is one aspect that I haven't actually completed. It allows you to rotate it in 3D on the X and Y planes, but I haven't set the 2D to adjust accordingly, so it's not really ready, that aspect. And then this other, which should not be called panel design, should be called component geometry or something like that. Covers all the different geometric aspects of the individual components. This will be probably split over 2 or 3 pages and have diagrams and so on. But for this phase testing, the user interface is really not that critical for this tool, as most of the functions are carried out in the 2D and 3D windows. Okay, and the final page is just representation, 2D representation of the visible elements. And your surfaces, the panels is an array. I will probably make a bit more of a feature out of this, so it's a little bit more graphically appealing. But it's quite clever as an array. It's quite efficient. If you want to, for instance, have a certain sequence, it's very easy to do that sequence in here and sort of see it in the grid. So let's say we just want to have every second material to be the, let's not choose something so bright because we'll leave it at that, forest green. Okay, so 76. If we want every second one to be 76, then you just simply copy and paste the 76 into the chosen cells. So copy, paste, 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 and so on. Just see if there's any more. Yeah, there's a couple more rows here. Columns, I should say. Okay. Click OK. And now we've got that green through the panels. That first panel also affects the color of the bulkhead element, which we've got assigned here. Okay, then you have just the other materials, and then you've got your sectional attributes. Okay, so as I said, apart from basically this panel design and the individual sizes of elements, the whole configuration of this element, the whole configuration of this object is done basically in the 2D view. So let's go there and start playing around with it, and I'll sort of show you how it works. Now you remember in the first video I had a function down here where you sort of turn off different guides. So that function's still there, but I've now extended into 4 different stages. So the way you basically configure this object is to run through those 4 stages. In this first stage, which is guide off, you've only got, I've taken out all the hotspots and all that sort of thing, so it's very uncluttered. Now you might want me to put those hotspots back in because you may wish to dimension to the joints, so you might want those joint hotspots in there. They are dynamic, and therefore you can associate the dimensioning to them, and the dimensions will change with the design. Now the first stage of configuring this tool, you basically grab this node, stretch it down 50 mil or 100 mil actually, and in 100mm increments, and that'll take you through the different phases. So you can see the phases here. I'll just run through them quickly and then we'll go through them in detail. So we have guide off, shape and openings, joints, boundary features, and hangers. Alright, so let's have a look at the first one, shape and openings. So if we zoom in a little bit, you can see the add node and the curve hotspots that basically do as they say. So you can simply add another node, put another one in here, maybe curve an edge, and so on. Do as you please to sort of configure the polygon that you need. In this stage of using the guides, you can also add holes. So we've seen this function in the early one as well. So you just scroll along to add a hole. Move it into position and adjust the size. You can also change it to a circular type hole, and you can then adjust different points in there as well. If you want to add another hole, you simply stretch along to the certain number of holes that you want to apply, and then you drag and stretch those holes into position. I'll just add a second hole here so we can have a couple. Okay, now this we're not seeing the hole right now. I will adjust this. So if we just do a quick refresh on that, that'll bring up that hole. Grab it, stretch it into place, and adjust its size. Okay, so now we've got two different holes. We've got a few different boundaries and some curves in there. You can sort of see how easily that works. Once you've done with configuring the polygon and the openings, you then go to the next phase, and that phase is joints. So this basically brings back those joint hotspots and allows you to start messing around with the joint placement and all that sort of thing. You can see here how it overshoots. That just needs a refresh. So if you make another move, then that'll clean up. Likewise here, that's now a little bit out of whack, but if you make another move, it cleans up and so on. Okay, so as we sort of went through earlier, part of this joint design or panel design, I should say, occurs in the user interface. So you can do quite a lot here when you're going for more of a free form effect, or if you want to adjust individual joints. But most of your work here will probably be done in the user interface. So we'll just go to that point and show you the different functions. So I'll just set this to the plan view. Now, firstly, you have the obvious nominate the number of vertical and horizontal joints. So if we can just reduce that to 4, you see it pulls a joint away. So bump it back up to 5 again, and the joint appears. Now it needs a little bit of a refresh, and its position relative to the other joint is just based on a minimum space. So there's no real logic in that unless you start to turn on some of this logic. So let's turn on some of that logic. First one is the equal spacing for V, for the vertical joints. So if we turn that on, that'll then position that in a more logical place. The next one is the equal spacing for the horizontal joints. Turn that on, and they become equally spaced as well. And obviously they square off in this. They're all horizontal joints will be 0 degrees, all vertical joints will be 90 degrees when you're using the equal spacing. So if you want equal spacing but want the joints skewed, then maybe we'll have to work something out with that. I could put some more logic in for that. Anyway, let me know if it's something that you need. The next function is just simply squaring off the vertical and horizontal joints. So if you tick this, I'll sort of show you first. Let me skew a few of these. So now once that I've turned those equal off, it frees up these joints again, and I can sort of just position them however I please. Now if I go back into the settings and I want to say square off all the horizontal joints, then I just check this box down here. So it won't adjust the first position, which is in the vertical it's the bottom position, in the horizontal it's the left position. All it will do is make the right position of the horizontal joints the same as the left, and the top the same as the bottom in the vertical. So we'll just see how that works. So square off horizontal joints, just sort of pay attention to these points here and watch how they change. Okay, so now they're squared off. Square off the vertical joints, once again pay attention to the bottom points and the top points and how they change. Okay, now they're squared off. So these are not equally spaced at all, they're just simply squared off. Okay, the next function is the sequencing function that was requested. So this basically allows you to set a pattern whereby the first two panel sizes repeat, basically. So if I click on, let's do the vertical one first. So with the Calpin V, it's not referring to the vertical joints, it's actually referring to the vertical panels. Where all these other V and H's refer to vertical and horizontal joints, this one refers to panels, so please don't get confused by that. So if I turn this on, you can see that's already starting to adjust based on these. Now the example that was given was a 600-900 repeating sequence, so let's set that up. Now remember these, so this is the first, the position of the first joint, horizontal joint, defining the vertical panel, and second horizontal joint. So obviously we want to set this first one to 600. Now the second one we don't want to set to 900 because it's not a distance between the two, it's the position of the joint relative to 0. So we need to set this one to 1500. Which is obviously 600 plus 900. Okay, so you can see that's affecting this side, so we need to square these joints off. So you use the square joints, so we might as well turn them both back on. Okay, now if we click OK, we'll have a look here. I'll whack in a quick dimension to just demonstrate that 600-900 pattern has taken effect. There you can see 600, 900, 600, 900, and so on. Okay, now I'll just do that with the other side just as a demonstration. So if we do the horizontal, tick that box, set this one to 600 and set this one to 900 plus the 600, which is 1500, and click OK. Okay, so you see we had a couple little problems. That's basically just going to be the placement of the joints interfering with certain things, so I'll sort of show you how that works. It seems this joint here, this joint's fallen completely out, so we can turn that one off. So that's number 5 of the vertical, so we'll just go down to 4. And this one here is going to be getting cut in a strange way and giving some bad results, so that's probably why that's not working. So let's just change this from a 600-900 to a 600-800 pattern. So that would be 1400. That brings that in and should eliminate our problems. Okay, so what was happening with that issue, this is something that you have to sort of be wary of, is when a joint is running into two edges at the same time, it basically computes a cut twice at the same value, and that obviously causes problems. I'll have to try and work out something to work around that, because there may be instances where that is part of the design, but for now, if you get an error and that's happening, then that's probably what your error is. Okay, that basically covers all your panel design functions. So we'll just turn all these off now, and we'll click OK. That now frees everything back up, so we can start moving things around if we want to. I'll just delete this dimension, and we'll go to the next phase. So now what you've achieved so far is your overall shape, your penetrations for whatever purpose that they may be, the joint configuration or panel design, however you want to perceive it. So the next thing is the boundary features. Where did they go? Boundary features. Okay, so with the boundary functions, basically you have a movable hotspot that allows you to choose between 4 options. So let me just change one of the fill settings in here so we can see that. Component that is great is the component that has been nominated. Now we also have a global features. So if you have a look right now, that global features is turned on. So when I try and adjust this, it's locked. I can't adjust it simply because we've got the global boundary features turned on. So that means all these features are controlled by this setting here. So you can see if I change that to cornice, they all change to cornice. Change it to joint, they all change it to joint, and so on. If we want to turn that off, we simply grab this node here, stretch it along 50 mil. It's only got 2 points, so if you just stretch it, whatever distance it's only going to go is the 50 mil. Click, and that turns that off. So now we can control each side independently. So let's say that we basically want joints around the whole thing, but we're going to have a bulkhead on a couple sides and maybe a cornice on one side, just for the sake of demonstration. So the quickest way to do that would be obviously to turn the globals on and set it to joint. Okay, just zoom in a little bit here and show you this. So first option, as you can see in the little pop-up, says global type joint, global type cornice, global type bulkhead, and global type nothing. So we'll choose joint. And then we'll switch our global boundary features off, and that now frees up all these features to be independently controlled. So let's go and whack in perhaps a cornice in this one and a couple bulkheads. Actually, we might leave it as joint, cornice, bulkhead, and off, so we can just see all 4 options in one small space. The function is also available obviously for the openings. So each opening can have its own boundary feature. So we'll just turn this one to joint and we'll leave this one at bulkhead. And then I can show you exactly how they look as well. You may have noticed that the elements don't necessarily meet. Okay, that's because I haven't done the equation, the algorithm, to determine the intersections. Instead, I've put in a custom feature so you can just control it yourself. Now, the reason for this is I will do something that automates this and also gives you an override, because there will be times you will definitely need to override it. The reason is it's not a simple equation to just get these values. When you do an evaluation of 2 lines and the angle that they make between them, you always get the acute angle, because the way the maths works is it only covers things within the range of 0 to 180 degrees, so you always end up with the acute angle. There's no way I can get this to automatically know in a very simple way with minimal coding whether you want to choose the acute or the obtuse angle. What I would have to do is put in a whole series of conditional statements saying, you know, what quadrant the first line starts in and what quadrant the second one's in, and based on that it nominates which angle. Put simply, there's a lot of maths that needs to go in to actually work out exactly what that angle is and therefore determine the bisector and get these things to meet perfectly. The other reason is that a bisector of the angle, whether it be the obtuse or the acute angle, is not necessarily going to be perfect because the 2 components may be of a different size and therefore you don't want the exact bisector. So let's have a look at that. Down here we have a joint and we have a cornice. Now I'm assuming they're slightly different widths. In fact, yes, they are. So if we nominate the bisector And ArchiCAD kindly gives us that. So if we just scroll, if we just pan around a bit, we get to the bisector eventually. I don't know if you can see that faint line that's appearing, but I am snapping to a bisector line there. So I'll do that, and you can see you don't get a clean intersection. You basically need to do it by eye. You could draw some guides for yourself if you wanted to get it spot on, but this is going to get you to within 1/10 of a millimeter accuracy anyway. It's probably something you're not going to see. Now, if you have two sides that are the same, so here we have two joints, then the bisector is exactly what you want, and it's very easy. You don't have to search for it by eye. You just basically find that line and click to it. I will, in the final version, have some aspect of that automated, but for now it's completely manual. So let's take a look at this thing in 3D. This side here is the bulkhead, that's the cornice, that's the joint. And this side over here, which I have slightly cut off there so we can get a good look at the bulkhead, that's the nothing. Okay, so let's have a look at this bulkhead. Now, the bulkhead is basically a joint with a panel attached to it. So if we come around and have a look at the joint, in this version I've nominated the T section for the joint. So I'll just go into the settings and show you that, as I don't think I've covered that yet. Okay, so in joints at the moment you can nominate a rectangular or a T section. If I just set it to rectangular, then obviously you just get a box section, and if I set it to T, then you get a T shape. So you get a T shape in the joints. Where's one that I can show you? Okay, so there's your T shape. So that's your joint width, that's your joint depth, and then these two values are also available through the T stem and T base thicknesses. So with the T section, the boundary joints become an L section. I didn't think there would be T sections on the boundary. I thought it would be an L section, so that's what I've done. If the detail is otherwise, then just let me know. Down here we have the cornice. So the cornice section is basically just a rectangular section again. There's no profile to it. If we need specific profiles, then just do some drawings, make a list of the profiles you need, and I can add in whatever profile you want. And now we'll just go back to the bulkhead, which you can see is the same L section as the joint with a piece of panel attached to it. And you can nominate the thickness of that panel down here. That's the height of the bulkhead, that's the thickness of the bulkhead. There are your cornice dimensions, frame dimensions, hanger dimensions, joints and panels. Once you've done that, there's really only one stage left to do to configure this item, and that is to set the hangers. So we stretch down to the next set of guides, and that brings up all our hangers. Okay, now I'll just get rid of this marquee. Basically, there's quite a lot of hangers here, and each one can be controlled individually. So each one can be stretched along its joint, the joint that it's associated to, or it can be toggled on and off with this function here. Now obviously, being that there are a lot of these elements, we need some global controls. So down here you've got 3 global controls. There are basically 3 type of hanger positions. There's junction hangers, intermediate hangers, and joint end hangers. So the junction hangers are the hangers at the junctions of 2 joints. The intermediate hangers are the hangers that are in between the junctions of 2 joints, and the joint end hangers are junctions on the end of the joints. With these controls we can turn them on and off as individual groups. However, these elements down here, they're not a locking function. You can alter individual components once you've adjusted these to basically what you want. So you sort of set these up and then you do some fine tuning. So let's just turn them all off. Stretch this node off, off, and off. Okay, so now that leaves us with absolutely no hangers. Okay, if you want to turn on a few individual ones, then you can. However, obviously the most efficient way to do this would be to turn on certain groups. So let's say it's a pretty small arrangement, so we don't need our intermediates. So we just turn on the hangers that go in the junctions, and we turn on the joint end hangers. Okay, now we have a look, and we just sort of work out whether or not we need anything else. For instance, we've got some long lengths here. Perhaps the longer lengths will actually need a hanger in them, so you can just go and turn on a few of those ones that are in the longer lengths. Okay, and that is basically how you set up your hangers. So that covers the configuration of the tool. Now, there are a few other things, so I'll just go through them briefly. Firstly, LOD. At the moment, the way I'm controlling this is through an MVO setting, and I've just created my own little Swift resolution MVOs. And here you can control the resolution and also the level of detail. I'm not using any standards in this. We can implement some sort of standard, use the LOD 100 to 500 or whatever it is that you want to use. But at the moment, we're just using the standard ArchiCAD parameter for the 3D detail level, and we've got coarse, medium, and fine assigned to that. The resolution is independent of these three settings. So let's have a look at this in 3D. The resolution will affect things like this. So it'll affect any curved element. If I go back to the MVOs and I change this from 36, just bump it up, say to 48, click OK, you see it's sort of starting to smooth this off. That's a pretty tight turn in there, so probably have to bump it up pretty high to get that to smooth out completely. Let's do 72. Okay, but that only affects curved elements, and as there are very few curved elements in here, unless you choose the round hanger, there's really very few curved elements, so it's not going to have a great effect on your polygon count, that aspect anyway. Let's have a look at the other two settings. The medium setting, I'll just put this down to something more reasonable. Okay, so if we go into the medium setting, click OK, it turns everything into flat planes. Alright, so I've used the plane code here, and that basically, there's a bit of you can see that in here, I haven't got the plane code actually working for curved elements perfectly just yet, so I need to do a few adjustments there. But basically it turns each panel into a single polygon, because the plane is just one single polygon. It's got two sides, but there's absolutely no thickness to the element at all. So that makes it a single polygon. So with a setup like this, you end up with, what have you got, 5 by 6 grids. So you got 30 at the boundary lines, 1, 2, 3, 4, 5, 6, 36. There's 2 in that, 37, 38, 39. It's 40 polygons with your hangers, which are also just simple planes. You're not even going to get up to 100 polygons in that, which is really small. The frame element, I haven't decided how I'm going to affect that geometry, so I kind of need a bit of feedback on that as to how you want. I would kind of think with this level of detail, you probably wouldn't show any frame detail at all, so we just sort of set it up as a mass. And that might be the same for the hangers. Okay, so the next level of detail is then coarse, and that just makes things, you know, even simpler from there. So click OK. I've got to get that plane in there, but it basically turns the panel into a single plane. Let me just quickly fix this. This is the bit that I haven't fully completed because it doesn't like these curving functions. See, illegal mask value, that's what it's talking about, the curving functions. So if I just go and just quickly get rid of that curve. Okay, and back to 5, and there we go, it's all fine. So that turns the whole thing into one plane. So rather than 30, we've got 1, and it makes the joints as just 3D line work. You've still got the same sort of detail for the boundary features, so that's still 2 planes, and I once again still need to resolve what to do with the frame in this regard. Now, 2 things to think about. Is this level completely unnecessary? Because it has reduced it obviously quite a lot, but perhaps the medium is as low as you need to go. So perhaps we need to make the coarse into the medium and the medium into something between what the current medium is now and the fine. So just think about that one. Also, do you actually want to control this through the MVO settings? This is going to be the only item currently that uses this. Obviously, we'd like to build a suite of items that use this element, but if this is the only item that's going to use this, maybe the MVOs are not the best for now. However, obviously being in the MVO settings means you can assign it to your drawing type, so it's a really powerful way to do things. The other thing is perhaps we don't want overall levels of detail for the thing. Perhaps we want individual levels of detail for different components. So perhaps you want the panels at detailed and the hangers at coarse, and so on. So have a little bit of a think about that. Okay, so that's basically it. Have fun. Do your best to break it. I'm sure in this early stage you'd be able to break it in a few different ways. So the important thing is send me the error reports you get in that. So make sure you got your error reports turned on. Options, work environment, model rebuild, I think. Yep. And interrupt with error messages. So make sure you got that ticked, and that will mean that basically when there is a problem, when you go into the settings, that little error will pop up here, and it'll tell you what line of code is problematic. Most of the times it'll tell you the line of code. So basically, whenever that happens, take a screenshot and send it along to me so I can start to compile the bugs and fix them, obviously. Okay, enjoy.